Okay, we're looking at loan minimisation. Now with loan minimisation, we're looking at how we can reduce the loan that we have quickly or more effectively. So there's probably three ways we can do that. One is to increase our payment size. Next one is to make more regular payments, and the best way to do this is to convert these to fortnightly payments. And we'll talk about that in a tick, or do some lump sum payments. So let's have a look at the first one. Let's have a look at just increasing the size of our payments. So we'll go to a standard question. This is what we had before. We had the $422,000 loan, 25 years, 5.76% is our interest rate. So the question has got three parts to it. How much interest was paid over this time, over the whole loan? How much time will you save if you increase your payments by $20 per month? This increasing your payment. And then how much money is this in real life terms? So to start with, we do what we did in the previous one of this. We enter in all our data and solve for payment. You've got to work out your payment first, because you can't do anything until you've got that. So when we do that, we end up with $2,657.38 is our payment on that. And now once again, if you look in the calculator, it looks pretty well similar to that. What we want to do is the next part of the question says, how much interest has paid over this time? So how much interest have you paid over this time? So if we go to this, we have to go to the amortization window again, like we did before. So you go to F6, and you grab your amortization window. The difference this time is we are looking at from payment 1, because we want to find over the whole period of the loan. So payment 1 through to the last one, which is payment 300. So we're looking for the whole loan. The whole loan here is how much interest are we actually paying. So in here, you put in for your amortization, you put in 1 at the first one, and then 300 for the second one. And across the bottom here, we want to find sigma int. We want to find out how much interest we're paying back. So if you go sigma int, you'll end up with $375,213.93. So you're paying a substantial amount of interest on that loan, $375,000. So nearly the same amount as what you borrowed. You borrowed $422, you're paying back $375 in interest. So it's pretty huge. The next part of the question then says to us, okie dokie, how much would you save if you increase your payments by $20 per month? So you've got your calculator sitting here with your NIPV payment, future value, payments per year, compounding period per year. Now you need to enter these in each time on your paper so we can see what's going on. So otherwise what happens is the person marking it is possibly not going to see what you've done, and if they can't see what you've done and you've just spit out a number in a solution, then you're not going to be able to prove what you've been doing. So fill in everything you've got. Now it all appears on your calculator, so it's there, so it's not too long. It just takes a little bit of time to actually write them down, and it's a good thing just to check that you've got the right numbers as you go. Okay, so we're going to increase our payments by $20 per month. So we're going to make this number here bigger. So because it's a negative number, we've got to take away 20. So that should take that to about $2,677. Okay, and then we want to find out how much time looking at finding n is what we want to find out if we do that extra payment. So when you grab your calculator, you've got just what you've worked out before. So we're just going to repeat. We'll go back to this window because we want that one there. If we scroll down to your payment, we want to increase that by $20. So scroll all the way across. Notice it says all the numbers in your calculator. Take 20. Okay, we've got to go take because it's a negative number. Go execute and see we've now got 2,677, whereas our first payment was 2,657. So it's a little bit bigger. I don't know if you're going to save too much time. Then we come down to N and go to N, and we'll have 295.06. So we now have 295.06 months. That's how long it takes to pay back the loan. You've got to go up to the next month, so it's 296 months. So you really only save 4 months in time. But remember, $20 a month isn't that big. You could actually increase that more and you'd have a bit of a better kind of outcome. But the last part of the question says, how much money is this? Well, if you've got 4 months that you have saved, and each month you're paying, we'll go back to the original one, each one, oh, that's funny, each month you're paying the 2657.38. If you work that out, you'll find out that you'll actually save quite a chunk of money. So you grab your calculator, you've got to get out of this window, go back to the main menu, get to this window here, to go 4 times by 2657.38. The 4 is because it's 4 months, and each month you pay 2,600. So you actually save, oops, I've lost that window, $10,629.52. So you actually do save quite a bit of money over that time. Now, if you increase those payments to more than $20 per month, you'd be way ahead. So it's a really good way of just reducing debt. If you've got a bit more money up your sleeve, regular payments, increase those payments, it'll get rid of the debt a bit quicker.